Hello everyone and welcome to my demonstration video and explanation of some of the implementation choices behind this 9-point measurement tool that I wrote to optimize this aspect of our workflow. You're looking at the main window in the GUI. Um, Here we have a control for the directory where the data gets placed, and then here I have a control for the Excel file template um, where I want to put. Ultimately, this is one of the most important things in this workflow. This is the document, the master summary calculations document that goes to the engineer for processing. Down here, I have the status window. This is a core philosophy that I have here where I like to show what's going on under the hood, so to speak, for audit purposes, for sanity check, sniff test, so that we know what is, why that is, how that is. I'm going to select the micrograph we already took. And here a window will open up that will allow us to um, detect the scale bar. This is the most crucial and consequential aspect of this. Everything else is meaningless if this isn't done accurately. I don't have the scale bar detection working perfectly. There's such variation between these scale bars, and I have a few pet peeves about that. I don't think that this scale bar needed to be 4 millimeters. It could have been a millimeter, and I don't know why they're shaped. Why anyone ever uses a scale bar that's shaped like a dumbbell like this. So, for instance, if I zoom in here, it is a bit ambiguous to me if this boundary is the final pixel here, which is what I would assume, or if it's like what this vertical line sort of truncates. Is it right here or something in between? I would rather this just be a solid line and it's just clear that it ends where it terminates. Um, so it auto-detected this segment here, 18 pixels per millimeter. Let's just do like a sanity check to even see if that's right. And it is. I can reset that again and pick something less than that. Seems reasonable. Seems reasonable. So I'm going to zoom out and select the left and right edge. Also seems reasonable to me. Let's go to the next screen. Here is the fracture surface of the CT specimen. So I am bounding the left and right edge of the notch. The notch is this valley here. This is the line from which the measurements are made for the final crack as well as for the pre-crack as well as the final crack zone. So you can kind of see the divisions here, the difference in texture. Sometimes it's not this clear. So also another, in line of that philosophy of seeing what's going on under the hood here, it displays how many pixels are between these bounding lines, converts it to millimeters. With the scale bar here, that seems reasonable to me as well. So let's hit space to confirm. So it comes in 0.01 B. B is like the specimen width essentially, right? 10% inset it comes in from either side per the standard. Okay, so now all the user has to do is select this boundary here for the pre-crack, right? This is usually a higher frequency fatigue region, like 6 hertz or so. And then here we're working with the final crack region, so this is a necking check, so this allows me to exclude if there's necking. It does seem that there's some curvature on the end here, so I'm going to hit M for manual measurement, and I am going to exclude that plastic zone from my measurements. So I'm clicking that final crack boundary. These are 9 evenly spaced lines resulting from dividing that one line by 8. So now it is processing these measurements and generating a PDF report, as well as opening the folder where the 3 main files that we care about are. So first, the PDF report, image of the sample, measurements overlaid on here. Some other information extracted up here. There's a little bit of statistics here. This is not cross-validation. This is the coefficient of variation. It's the standard deviation divided by the mean. And the standard says that this shouldn't exceed 10%, but there are reasons that it does. It's not something that we have to strictly comply with all the time. There are reasons that it's outside of that, such as material properties, processing history, environment, and so forth. But it is good to report this and to have this here. Let's look at the Excel file. Again, this is the master summary calculations document. This is sort of this is the document from which all of the other data processing originates. So I have the measurements that we took ported in here automatically for the pre-crack as well as for final crack. And then the Excel document has computations in here where it performs on these measurements here. And in this tab, the specimen image with the measurements overlaid on it is ported. I do want to change this so that I'm going to change this so that this is just ported right here. It's easy for the engineer to see. We also put the pre-crack data in this file as well as the DCPD measurements from the environmental test. There are other things that I can do to really save even more time in this processing workflow that we do all the time, maybe 100 of these a month, and cumulatively I can cut down that time so that we can focus more on quality and just selling more work. I really appreciate your time. Thank you for listening, everyone.